Okay, so we're going to get started now with section 1.1. This section is on inductive and deductive reasoning. So before we start the problems here in your workbooks, I'd like to give you a definition. So I'm going to stop sharing. I'm going to write down some definitions here. So this is section 1.1. Inductive and deductive reasoning. So I'm going to try to give you very simple but yet clear definitions on the two types of reasoning that we will cover in this section. Inductive reasoning is whenever we're analyzing something um, based on specific examples of, say, something's taking place, we perform an experiment and we're seeing a specific outcome, and we examine specific examples, and it continues to happen. The same outcome continues to happen, repeats and repeats and repeats and repeats. And so after some point, we can conclude we can draw a general conjecture, basically. So we can define inductive reasoning as a method of drawing conclusions inductive reasoning as a method of drawing conclusions by going from the specific to the general. And so the types of problems we will see in this section will include both inductive reasoning and the next definition I'm going to give you is deductive reasoning. Deductive reasoning is a logical approach. We can define it as a logical approach. There are different ways to define it, but this is a simple yet clear way to define deductive reasoning. A logical approach where we progress from general ideas to specific conclusions. Okay. All right. So those are the two definitions I want to give you. And now we can go back to the problems. Let me share my screen. Like I have done in the past, I'm not going to cover every problem. So I will give you a model and go from there, because we don't want to make these videos too long, right? So we can start by looking at number one. And look at number one. We have a sequence of numbers, and it says use inductive reasoning. So here they're telling us what to use. Use inductive reasoning to find a pattern, and then make a reasonable conjecture for the next three numbers in the sequence. So this is inductive reasoning. We're looking at specific examples of outcomes that are taking place, and then we want to draw a general conjecture based on the specific outcome. So we're going from specific outcomes to general outcomes, right? And so we look at the sequence, and so I'm going to write it down, and and then I'll stop sharing once I write down the problem. So just give me 1 second to write it down. We have 7, 10, 16, 25, 37, 52, 70, 91, and then we are asked to find the next three, right, numbers. Okay, so what's really happening here? Let me stop sharing. Okay, so we want to see what's going on here. So one way we can try to solve this problem, find the pattern, is by looking at what happens between the first two numbers and then what happens between the next two numbers, and so on. So in order to go from 7 to 10, I see that I added 3 here, right? And then what happens when I move on to the next pair, 10 and 16? Here I added 6. Okay. And then what happens when I go from 16 to 25? I add 9, right? And it seems like, well, let's keep going. Let's see if this holds. So 3, and then 6, and then 9. Okay, so if the pattern continues, then if I add 12 here, right, it should give me 37. And if I add 15, I should get 52. And if I add 18, I should get 70, right? If I add 21, I should get 91. It seems like I found the pattern, right? So the next thing would be to add 24. And so if you add 91 plus 24, that will give us 100 and, well, I have my calculator here, don't think I know. 91 plus 24 gives us 115. And then I'm going to add 27, right? Another, because I add 3 every time. So plus 27. The next one is 142. And then if I add 30, I'm going to get 172, right? So what are the 3 numbers I found? The next 3 numbers would be 15, 142, and 172. Okay? So that is number 1. And so that's how you would solve number 1. And you can follow this method to find other patterns, right? So let me share my screen and go to the next question. So you can do number 2, right? I'll move on to number 3. And it says, use inductive reasoning. So as you're looking at that problem, I'm going to write down the problem here. And I have some, notice that these are, so it says use inductive reasoning to find a pattern and then make a reasonable conjecture for the next item in the sequence. So the same instructions we have, right? But now we have these drawings here. So I'm gonna kind of see like, okay, so the first box has no shading, right? And then the second one has a shaded little box at the bottom right side. And then the next one has 2 unshaded little boxes. And then the next one is 3 shaded on the corners of the main box, right? And so you can see that the next one, well, based on this, let me stop sharing. So based on what we observe, we can conclude that the next would be, the next box would be the 4 little boxes unshaded, right? So that would be the next item. Okay? Right, so that's number 3. Okay, let me go back to, and you can do number 4. I recommend for number 4 that you look at, I'm going to give you a hint for number 4. And then I want you to try it, but I'll give you a hint. Okay, so how to look at it. Look at the first 3 drawings from going from the left, reading it from the left side. So you see you have a rectangle here, and then inside you have another figure. Notice that the inside figure, I'm just going to call it inside and outside. The inside figure becomes the outside if you go from left to right, right? And then the outside figure becomes the inside going from right to left. Once again, going from left to right, as you're reading this, the outside figure, right? Notice the outside figure and then the inside figure. The inside figure becomes the outside, going from left to right. The inside becomes the outside. And going from right to left, the outside becomes the inside. So use that reasoning for the next 3 figures here to figure out the missing one, okay? And then you can look at remember at the very end of the workbook, you have the answers at the very end of the workbook. The answers are provided so you can check your work, okay? So try number 4. Okay, and moving on to number 5. Number 5 here, it says that it's given me a statement and I need to figure out, let me look at the instructions. It says, find a counter example to show that the statement is false. Okay, whenever you're finding a counter example, you're trying to prove that something is false. You do not prove things with an example. You disprove things. You can disprove statements with an example, right? If I say all Mexican women are tall, and by tall I mean taller than 5'8", I can disprove that statement by finding a woman who's Mexican who is not 5'8", right? So it is enough to find one example that will disprove the statement, right? So that's what we're doing here, finding a counterexample. It says a number divisible, it says a number is divisible by 9 if the last 2 digits are divisible by 9. Okay, so let me write down. I'm not gonna write down the statement, but it says a number is divisible by 9 if the last 2 digits are divisible by 9. Okay, so you can disprove that. I can think of the number. I can think of 136 as an example. Let me show you why this fails. 136. It's the last 2 digits are divisible by 9 because the last 2 digits 36. Notice 36 is divisible by 9, right? It gives me 4. But 136 is not divisible by 9 because when you divide 136 by 9, you don't get a whole number. You get 15.111 and it repeats. Okay, when I write the bar like this, it means it repeats. Okay. So you see how it is. So 136 works as a counter example. Also 118 will work, and you can come up with more examples. Okay, so a counter example is just basically finding one case where it's not true, and that's enough to disprove the statement. Okay, so that's number 5. And let me move on to number 7. Okay, so it says, select a number. Well, let me read the instructions. Use inductive reasoning to make a conjecture about a rule that relates the number you selected to the final answer. Try to prove your conjecture by using deductive reasoning. Okay, so I'm going to show you what it means to prove a conjecture. So first we have to select any number, and we need to see if what happens when we select a number and we apply these rules. Okay, so go ahead and select. So I'm gonna select a number, and let's say we select the number 7, right? And then, or let's select something like yeah, it can work with any number, but let's not select number 7. Let's select number 4. So, but it works with every number. So select 4. And then we're going to apply this process. So, okay, we're going to multiply it by 9. Let me just go ahead and write this down, and then I will stop sharing. So multiply by 9. It gives me 36. Then I'm going to take whatever I get and add 21. It says add 21 to it, 36 plus 21. I'll stop sharing. And then divide it by 3. So I'm going to divide that number by 3. And then it says subtract 3 times the original number. So that would be subtracting 12 in my case. And I'll show you what I did. And then the end result should be 7. So let me show you what I did. And okay, so here's what we began with. So let me show you here. So we select any number. So you can select any number. So I selected 4, right? And then it says multiply that number by 9. So I did 4 times 9 gives me 36. And then it says whatever you get, you add 21 to that number, you get 57. And then divide by 3, you get 19. And then subtract 3 times the original number. So 19 minus 4 times 3, because 3 times the original number, and then subtract that. So you're subtracting 12. And then the result is 7. Okay, once again, following the instructions, you select any number. I selected 4. Then you multiply it by 9, you get 36. You add 21 to it, you get 57. You divide by 3, you get 19. And then you're gonna subtract 3 times the number that you selected. So you can write 3 times 4 instead of 4 times 3 here. Maybe that would make more sense here. So it's 3 times the 4, which is 12. 3 times the 4 is 12. You need to subtract that from the 19 that you had previously, the previous result, which gives us 7 as the final answer, right? So we see that by applying these steps, you're getting as a final answer, once you apply all the steps, you're getting 7. Now, this doesn't prove that this is true for every number. This only shows you that it works for 4, right? So if you wanted to prove this for any number, you need to select a random number. A random number like X, for example, right? And so you can start by, for example, you can select X and apply. So now let's prove it. And let's go back to let me show you in the workbook, it says, in the result, it says, if you select the number X, then the result is, so here they're saying prove it with any number, right? So let's see if it's gonna work also, if it's gonna give me the same thing. So select a random number. Let me lower this. And so I'm gonna select X, right? And then I'm gonna multiply by 9. Next step is you multiply this by 9. So you get 9 times X. So you get 9X, okay? And then it says to add 21 to it. So the next step is to add 21. So you get 9X plus 21, right? And then it says divide by 3. So you write 9X plus 21 and divide by 3. Well, you need to simplify this. So you get 9X divided by 3 plus 21 divided by 3. 9X divided by 3 is 3X. And 21 divided by 3 is 7. So it's 3X plus 7. And then it says subtract 3 times the original number. So the original number is X. So I need to subtract 3 times the original number. So you get, okay, so this is what I have. 3X plus 7 minus 3 times the original number minus 3X. You see how 3X and minus 3X cancel, and you get 7 as the final answer, just like in the previous example, right? So you see that this actually works for a random number. This does prove it. This is a proof that it works in the general case. So you have proof that this works, okay? So this is true for any number, all right? Okay, so let me go back to the workbook here. So that was number 7, okay? And let's see, number 7, let's look at number 9. Again, we're gonna use inductive reasoning to find a pattern for the answers, and then use the pattern to guess the result of the next 3 calculations and perform the operation to see if your answers are correct. Okay, so we are going to look at what's going on here. So we're trying to find a pattern here on the factorials. Hmm, notice something interesting here. So let me write down this one. If you're not familiar with, if you know what factorial is, then this is going to be really simple, right? But I'm going to assume that you do not know, and I will just explain how they came up with this, okay? Let me just write it so it makes sense. And then okay, these are factorials. So notice 1 factorial is just 1. So that doesn't really help me much because I don't know how they come up with that, right? But then the next one is 2. How do they come up with that? Well, one hypothesis is that perhaps, you know, they added 1, right? Maybe, but that doesn't hold for the next 2. You see, if I conclude that they added 1, if I add 1 on the next from 2 to 6, that doesn't give me 6, so that doesn't work. So adding 1 is not what works. So from 1 to 2 is 1, and from 2 to 6 is 4. How do they actually come up with that? They added from 2 to 6, they added 4, but then they go from 1 to adding 1 and then adding 4 and then adding 18 here. So addition is not really the pattern here. I don't think that's going to work. You see, so you have to find, it's a trial and error. So you try addition, but I don't think addition works. Then you try multiplication, and you see how, well, 1 times 2 gives me 2. So here, 1 times 2 gives me 2. That works. And then over here, 1 times 2 times 3 gives me 6. So that works too. And then 1 times 2 times 3 times 4. That's 6 times 4. That gives me 24. I think we're up to something here. 1 times 2 times 3 times 4. That's 24. And then times 5. Well, that give me 120. Let's see. 24 times 5. Let's see. Yeah, it gives me 120. You can try one more just to be safe. 1 times 2 times 3 times 4 times 5 times 6. And that gives us 720. Okay, so we found the pattern, right? It's all multiplying from 1 up to the number. Okay. And so you can see that 7 factorial is going to be 1 times 2 times 3 times 4 times 5 times 6 times 7, right? And that's going to be, you see, 7 factorial. And you can figure that out. And that's going to be 1 times 2 times 3 times 4 times 5 times 6 times 7. That's 5,040, right? And then the next one, right? That times 8, that's going to be, I can just write it here. So the 8 factorial will be 40,320, and then times 9. The next one is going to be really, really big, 362,880, right? And so on, okay? So that is, you should get 5,040, 40,320, 362,880, okay? For the next 2. All right, any questions on, oh, I'm sorry, I thought I was lecturing. You can't answer back. I apologize. You can't ask questions because we're not live, right? Sorry about that. I really thought I was in a lesson, in a live lesson. Okay. All right, moving on to the next one. Number 10, what's going on with number 10. It's really, I mean, I let you work number 10 so you can see the pattern here, but let me give you a hint. Okay, you see how the first one, notice that you get 3/2, right? For this one. So you're wondering like, okay, how did they come up with 3/2? Well, let's look at the next one, 5/3. Okay. And then the next one is 7/4. What I'm seeing is that the denominator, if you add the denominators, notice here, if you add the denominators, you get the numerator, right? 1 plus 2 gives you 3. And then the last digit of the denominator becomes the denominator. So 1 plus 2 is 3, and then over 2, which is the last digit. So if that works on this, let's look at the second line, should be 5/3, and then the third line should be 7/4, right? And you can see the logic here. So this one is, I'll let you work this one, just kind of because you need to be trained on spotting these things, okay? So, oh, I'm sorry, I wasn't sharing. Let me go back to the, I apologize. Let me share. So, and I will explain again. So number 10, I was looking at number 10, and I see that the answer for the first line is 3/2, right? Now look at the second fraction in the middle and look at the denominator. And if you add 1 plus 2, you get 3, right? And then 3/2 for the first one. And then the second one, you do the same thing. 2 plus 3 is 5/3. And then 3 plus 4, 7/4. And then 4 plus 5, 9/5 should be the next one, right? And so I gave it away already. So you can see the logic here, okay? All right, so try number 10 on your own. And the last two questions, we have, I'm gonna do, you have, these are statements, right? We're gonna be reading together. So let's take a look at 11. We'll do this one, and then I'll do 11 and 12. Okay, and then you guys can do the rest for practice. So like I said, I don't want to make the videos because these are just statements that you can work on your own. So I'll do 11 and 12, and you guys can do the rest. So 11 says for the first, so what are we supposed to do? Determine if we have deductive or inductive reasoning. Inductive reasoning is going from the specific to the general, and deductive reasoning is the opposite, going from the general to the specific. So when let's read 11. For the first 3 games this year, okay, so here we're looking at specific things. For the first 3 games this year, the parking lot was packed with tailgaters. So we will have to leave extra early to find a spot this week. Notice that we are making general conjectures based on specific outcomes. So that's inductive, right? That's inductive. You're looking at some specific outcomes, and then you're concluding, you're making a general conclusion on what's gonna happen, right? Okay, so that's inductive reasoning. Now let's read 12. Experts say that opening email attachments that come from unknown senders is the easiest way to get a virus on your computer. Shauna constantly opens attachments from people she doesn't know, so she'll probably end up with a virus on her system, right? So we are based on this general assumption that if we do this, something's gonna happen. Then because she's doing this, she's gonna experience this bad outcome. So from general to specific, right? From the general conclusion, we're going to apply it to the specific case of Shauna's case. So that's obviously deductive reasoning, okay? So be very careful about when you read it carefully. Understand inductive reasoning from the specific to the general, deductive reasoning from the general to the specific. And if you have a question with number 13, 14, and 15, just email me and we can have a discussion. Now you're always welcome to, you have access to the Tutors in Math World, virtual Math World. you can have a tutor online, you know, face to face on Zoom, or you can always ask me to schedule a session one-on-one with you. Okay, so don't think that because this is an online class, you can't email me and ask for that. And I think I covered that in the introduction video. So we can always do Zoom and have the tutoring session one-on-one if you have a question. So I hope this video helps you with this section. All of the videos will be uploaded in Canvas, and also you can find them on YouTube. If you go to SPC, SPC or SEALFLETS, SPC-MATH, something like that in YouTube, because I have two different YouTube channels, but one is specifically for math. So you can find it there. But I will make sure you have all these videos in Canvas, so you don't have to look anywhere else, right? But you feel free to check out those channels, okay, if you want to. All right, so that's it for this section. I hope you guys enjoyed it, and I will see you on the next one. God bless.